Welcome to this short video on finding the inverse of a 3 by 3 matrix by performing row operations. The inverse of a matrix is needed for so many other operations, such as solving a system of linear equations by the matrix inversion method. So the ability to compute or find the inverse of a 3 by 3 matrix becomes critical. In fact, we are going to use row operation method to find the inverse of a matrix of a 3 by 3, but the same method is applicable to other higher order matrices such as a 4 by 4, 5 by 5, and so forth. So let me go through this by using an example, a simple example. Let me assume that we have a matrix 1 minus 2, 4, 2, minus 3, minus 6, minus 3, 6, 15. And we are required to find the inverse of this matrix. So it's a 3 by 3 matrix. So to find the inverse of this matrix, you have to rewrite this matrix as you reproduce the matrix on the extreme left, that is 1, minus 2, 4, 2, minus 3, minus 6, minus 3, 6, 15. But then we augment with its identity, which is a 3 by 3 identity. Take note that if the original matrix given was a 4 by 4, we would augment it with a 4 by 4 identity and so forth. And I want to encourage those people who are not familiar with row operations to pause the video a bit. Look for a video that talks of how to perform row operations or column operations. Once you are familiar with those operations, you can then come and watch this video. So what is the strategy here? The strategy here is to perform row operations across this now augmented system, so that what we have on this matrix, it must be an identity, obviously a 3 by 3 identity. And what will result this side will be A inverse. That is the process. So we want to perform row operations. Make sure we create an identity on the extreme on our original matrix. But as we are creating an identity on our original matrix, we are also creating an inverse on the right side identity. So how do we do that? For those who are familiar with the row operations, since we already have a pivot 1, we want to create a 0 here and a 0 here. That is the first key. That is the starting point. So to do that, we say row 2 must go to row 2 minus 2 row 1. And the row 3 must go to row 3 plus 3 row 1. If we perform these two row operations, what we are going to have is the first row remains as it is because we are not doing anything on it. But for row 2, it will be 2 minus 2, which is 0, minus 3 minus 2 times the minus 2, this is 1, minus 6 minus 2 times 4, minus 6 minus 2 times 4. I think the original system should have a negative here. It was having a negative. So it will be minus 2 times minus 4, it's plus 8. So minus 6 plus 8, this will become 2. 0 minus 2, this is then minus 2. 1 minus 0, 1. 0 minus 0, 0. Then minus 3 plus 3 times 1, 0. 6 plus 3 times minus 2, 0. 15 minus 12, 3. 0. plus 3 times 1, 3, 0, times 0, 0, 1, 1, plus 3 times 0, this becomes 1. Right. So the next strategy, or the next step, you can see we already have a pivot 1 here, which is what we want. So we want to use this 1 to create a 0 here, but already here we have a 0. Equally so, we want a 1 here. So I can quickly perform row 3 goes to 1 over 3, row 3. That row operation, I can quickly perform it. So I will have 1 minus 2, 4, 1, 0, 0, 0, 1, 2, minus 2, 1, 0, 0, 0, 1, 1, 0, 1 over 3. Okay, sorry. It's not visible. So you see, it's just dividing throughout by 1 effect. So what is the next operation? I think I need to perform 2 additional row operations because I already, on row 1, I'm already, on row 3, I'm already okay. I have my zeros, but I want a 0 here. I want a 0 here. And I want another 0 here. So what must I do? Row 1 goes to row 1 plus 2, row 2. Row 2 goes to row 2 minus 2, row 3. You can see that row 1, if it's going to row 1 plus 2, row 2, I'm going to create a 0 here. So let me perform the row operation and see what I'm going to have here. This remains 1. Row 1 plus 2 times 0. It's just 1. Minus 2 plus 2 times 2. Minus 2 plus 2, 0. 4 minus 2 times 2, 0. 1, 1 minus 2 times 2, minus 3. Right, minus 3. Then 0 minus the 2 times 1, minus 2, 0. Then only this row 2 goes to row 2 minus 2, row 3. This is 0. 2, 1 minus 2 times 0, it's 1. 2 minus 2 times 2, 0. Minus 2 minus 2 times 1, minus 4. That should be minus 4. 1 minus 2 times 0. So that should be 1. 0 minus 2 times a third, minus 2 over 3. But the other one remains as it is, 0, 0, 1, 1, 0, 1 over 3. So what do we have now? What we have is an identity, a 3 by 3 identity. What we have on the extreme right is A inverse. So, ladies and gentlemen, what we've managed to demonstrate is how to use the row operations method to find the inverse of a higher order matrix. So you need to understand the row operations and the strategy for performing row operations for you to really take this method at ease. So You rewrite your matrix in such a way that we have an identity on the extreme right. Perform row operations that are meant to transform the original given matrix into an identity. But as you are doing that, you are also transforming the identity matrix into A inverse, which is what you want to find. Thank you very much. We meet again on how to use the adjoint method to find the inverse of a 3 by 3 matrix. Thank you so much.